Now we're going to begin solving radical equations where the variable that you're solving for is trapped inside of a radical. Basically, these are your steps. You're going to first isolate the radicals to get it by itself on one side of the equation. Then you're going to square or cube each side of the equation depending upon what the index is. Then you'll solve the equation, and it's very important that you check your solutions because sometimes when you square or cube both sides of the equation, you raise the degree and you get some extraneous solutions that you don't want in there. So please check your solutions. Here we go with our first problem. In order to isolate the radical, we want to add 2 to each side of the equation. And so this will give us the square root of 9z minus 5 is equal to 11. Then what we want to do to remove the radical is square both sides of the equation. And squaring the left will undo the square root, so to speak, and leave us with 9z minus 5 equals 121. Now we just have a linear equation to solve. Adding 5 to each side, we have 9z is equal to 126, and therefore z is equal to 126 over 9, which reduces to 14. Now let's check our answer. 9 times 14 is 126, minus 5 is 121, square root that 121 to get 11, minus 2 equals 9. So yes, it does check. This second problem has a 1/3 power, which is like a radical. What we're going to do is subtract 2 on each side. When we do this, we now have k plus 18 to the 1/3 power is equal to negative 2. Notice a cube root is allowed to equal a negative. If this had an even denominator equal to a negative, that would be an even root radical equal to a negative, and that would have told me right off the bat no solution. But as is, we're okay. We're going to undo the 1/3 power by cubing each side. You could say that we're going to raise to the reciprocal power to undo these exponents. Notice when you multiply reciprocals, you're just going to get 1 there. So on the left we have k plus 18, and on the right, negative 2 all getting cubed is negative 8. Subtracting 18 on each side, we are going to get negative 26, which we do need to check. We substitute the negative 26 in, add 18, we get negative 8, cube root that negative 8 to get negative 2, plus 2 equals 0. So yes, that does check. This next problem is a little bit different because we've got a binomial on the right hand side. Yes, the left hand side already has the radical isolated, and so what we need to do is we need to square both sides to undo the square root. Squaring the left just lifts off the radical, giving us b squared minus 5b minus 8. On the right, the common mistake is for people to write b squared plus 49, missing the 2 middle terms of FOIL. So I recommend that you rewrite this as b plus 7 times b plus 7 and actually do the foiling. We're going to have b squared minus 5b minus 8 is equal to b squared plus 14b when you combine the middle terms plus 49. When we go to try and get all the squares to one side, notice how the b squareds are going to cancel each other out. Let's get all the other terms to one side, or let's actually get the linear terms to one side and the constant to the other. Subtracting 14b on each side and adding 8 on each side. We now have negative 19b is equal to 57, and dividing by negative 19, we get b is equal to negative 3. Now let's check this answer. Negative 3 first on the right, negative 3 plus 7 is 4. Okay, square root equals a positive 4, that's good. Negative 3, square it, we get 9. That becomes plus 15, which is 24. Minus 8 is 16. Square root of 16 equals 4. Everything is good. b equals negative 3 is our solution. For this next problem, we want to first isolate the radical by subtracting 2 on each side. We will now have the square root of 5y plus 1 is equal to y plus 1. Now we see that we can square each side, and that means we're going to have a FOIL problem on the right hand side. So we've got 5y plus 1 is equal to y plus 1 times y plus 1. Doing the FOIL, we have 5y plus 1 equals y squared plus 2y plus 1. And it's a quadratic, so we want to set it equal to 0. I'm going to begin by subtracting 1 off of each side, so the 1's will disappear, and subtracting 5y off of each side. Now we have 0 equals y squared minus 3y. That right-hand side is going to factor, so we've got 0 equals y times y minus 3, and it appears that y will equal 0 or 3, both of which need to be checked. So let's start with 0 up in the original problem. 0 times 5 is 0, plus 1 is 1, which square roots to 1. So we got 1 plus 2, 3 on the left. When we substitute 0 in on the right, 0 plus 3 is 3. So 3 equals 3, and 0 is a solution. Let's check the other solution of 3. 5 times 3 is 15, plus 1 is 16. That sum square roots to 4, plus 2 is 6. So 3 going in gives us 6 coming out. Now on the right, 3 plus 3 is 6, and so that checks also. And so both 0 and 3 together are the solution set.